Okay, the next part of Math 1270 is going to be talking about, still talking about equations, but a little bit more complex. You got rational or fractions in your equation. How do we deal with that? And then we have decimals. How do we deal with that? And then we got some geometry story problems. We're going to talk about those. And then some percentages. But some things that I wanted to show you here, when you have fractions in an equation, we can actually still solve it like we always did. It's just combine like terms. Like if I wanted to bring the half over, so I can subtract a half from both sides. As there's nothing to simplify on the left or the right side, so that's why we just start shifting things from left to right. So now I have -1 and 1/2. And this move here, you can use your ABC button on your calculator to do that. Or another way of doing it is getting common denominators. All right, so -1 minus 1/2. Okay, well that would be equivalent to, if I multiply top and bottom to get by 2, so that you have common denominators, you would have -2/2 minus 1/2, which then -2 minus 1 would be -3/2. You say, well, you wrote, how is this and this the same? That's going from an improper to a mixed fraction. So 2 goes into 3 one time with 1 remaining. Or the other way of looking at it is you take the bottom number, so you take the bottom times the number out front, and then add your numerator. So add the top number to it, and then keep it over the same number on the bottom. All right, so there's where your 3/2 will come into play, and the fact that it's negative, you just would keep it the negative sign. Okay, so -1/2, so it would be a -3/2. Again, your calculator will do that, so you can combine those. But again, how do you do this in your calculator? Right, that's kind of why I just talked about doing and how do I combine like terms. All right, so if this is negative, the only thing I have left is -3/2 here. Okay, so what is x over 5 minus x over 2? Okay, well the LCD, or the least common multiple between 2 and 5, is 10. So I can make that a 10 by 2. I can make this a 10 by 5. And then I can combine these fractions. So I have 2x over 10 and 5x over 10 equals -3/2. And then 2x minus 5x is -3x over 10 equals -3/2. Okay, so now that you're here, you can just you can solve it like a proportion. You know, cross products are equal. That's one way of doing it. You say, well, that's -30 and that's -6x. That's probably the quickest way, actually. And then you just divide by -6 to realize that x is 5. And then you're done. Another way of looking at it, just so you can go through the math of understanding fractions, is that if we have this and we didn't cross multiply and divide, okay, we can multiply both sides by a 10 or a 2, right? And multiply by that denominator. I'm choosing 10, and what will happen here is that these 10s would cancel, just leaving with -3x, right? Replaced with 1. We talked about that in the previous video. And then this one here, that would be a 1, and that would reduce down to a 5. So then that's just -15, and then divide to get your +5. Now, with all that being said, all right, that's all fine and dandy. Yes, you can use your ABC button on your calculator, but what would happen if you just multiplied everything? So I'm going to box this in, show you how much shorter this method is. If you multiply both sides of the equation by the LCM. So if I look at all my denominators, okay, I see 2 and a 5. The LCM between 2 and 5 is 10. So if I let's add all the multiples of 2, let's add all multiples of 5, okay, 10 is the least one in common. So if you multiply the entire function by the LCM, you're going to get rid of all fractions altogether, and you don't even have to worry about having your ABC button. All right, so again, the 10 is being multiplied to everything. So if I just focus on one thing at a time, on the left side, if I have x over 5 times 10, okay, we can cross reduce, make that 1 and a 2. So then you're just left with 2x over 1, which then again is just 2x. So this is just 2x. All right, and then if we look at the next one, 1/2 times 10. Okay, again, we could cross reduce again, make that a 1 and a 5 and realize that it's 5, or you can multiply across and then divide to realize that it's 5. All right, so that's the benefit of cross reducing to get that same answer. All right, but we have a positive 5, and then here we would have, so on the right side of the equation now, x over 2 times 10 over 1. Again, these 1, 5, so now I just got 5x, and then a negative 10. So now, by multiplying that by the LCM, you get rid of fractions. And now it's just back to where you're comfortable with. Combine the like terms on both sides to make it a two-step equation. Get rid of the constant, and then divide, and then there's your 5 again. And it took up half the work. So you can choose how you want to tackle those problems. Now, as far as decimals are concerned, you can go through and just use your calculator. Right, it's supposed to be an equal sign, and go from there. Or, I'll do this over here, you can also multiply by a multiple of 10, because when you, this is kind of getting into scientific notation a little bit, but basically if you multiply something by 10, which is what we would do here, you're going to move all your decimal points one place to the right. And it's basically however many zeros you're going to, so if I multiply it by 100, you'd move the decimal point 2 places because it has 2 zeros. So if I multiply everything here by 10, okay, you would have 30x minus 38, so no more decimals there, okay, and then this is going to be, so this had to go to both of those because of the minus sign. Now when you take the 10 to here, this is where it gets a little bit tricky, okay, since it's 1.4 times all of the x minus 5, you can technically just take, here's what you would actually have. All right, you have 10 times 1.4 times all of x minus 5. So you're not going to take the 10 to the x and the minus 5. You just have to take it to the 1.4 and make it 14. And then, so by multiplying by 10, you take away all decimals. Okay, but I think it's almost just as easy just to use your calculator and use the decimals. I just wanted to point that out. All right, so if we do this, we get negative 7 when I distribute that through. And then it's just a matter of solving it just with decimals though. So 3 minus 1.4 is 1.6. So we're going to add 3.8. Okay, so negative 7 plus 3.8, negative 3.2, and then we're going to divide that by 1.6. And when you do that, you get negative 2. Versus over here, okay, you're going to distribute through and do the same process. So hopefully we get the same answer. Okay. So we add 38. Okay. We get negative 32 there. And then divide. And there it is again. Okay. So I encourage you, you can use your calculator with that one. Really, the only one that would really save you time is multiplying by the LCM with fractions. But you can just continue like I did over here. You can just do the fractions just like we with your ABC button on your calculator, or go through and take the time and actually figure out the common denominator and combine them like we did here and here. In fact, right here, you wouldn't have a choice. The calculator doesn't have variables to work with, so you would have to understand that concept there in order to combine those like terms. Unless you do here, the LCM, then that is obviously so much easier. Okay, next thing I have it laid out, so I'm going to go through these a little bit quicker. Here's all the percentage problems, then we got some geometry problems we want to work through. So now we're getting into, as far as this book is concerned, we're getting into from section 5 and through section 7. So we're still in chapter 2. And there's two ways to solve percentage problems. Actually, percentages is in section 4, so it kind of overlaps with the last video. I like to teach students to do these just using the is over of proportion. Most students learn it that way. But there's also another one, which is just using the equation, where is A is a percent of B. So your of, okay, and then your B is also, and then you got your percent, but this percent here needs to be a decimal. That's the key. Of course, is, anytime you see that word is going to refer to equals. So, and then, so if we have this problem here, what is 5% of 20? So the of is going to be associated with the B, okay? So if I use the equation, just draw a little arrow over here, you say, well, 0.05, right, 5%. 5% is the same thing as 5 out of 100, and when you divide by 100, it's going to move it 2 places to the left. Versus, as I just mentioned before, when you multiply by 100, it move it 2 places to the right. All right, but you take 5% of, so you would times it by 20. All right, so you do that, 5% of 20, and it's going to be 1, and then you're done. But if you do the proportion, you'd get the same answers. All right, so you stick your 5 there. The key here is that you don't have to make that a decimal like I did here. Okay, with the proportion, you don't have to do that. And is, we don't know, of 20. And then we just cross multiply, and we solve this. So 100x equals 20 times 5, which is 100. And then you divide by 100, and then there's your 1 again. So let's try both of these again using the proportion and the equation. I'll start with the equation because I seem to think that's a little bit easier. This time we know the is, okay, we just don't know the of. So 30% of what? All right, so and then I just have to divide both sides by 0.3. So 6 divided by 0.3 is 20. Okay, so 20 is a larger number. So here we want to know the of. And we get the same thing here. So when I cross multiply this, I got 30x, 600, and then 600 divided by 30, is your 20 again. All right, so it's totally up to you. One more time. This one here, we want to know percentages. Okay, so I don't know the percent, but I know the is, and I know the of. So there's that. And then here, I know the is. I don't know the percent. Okay, and I know the of. Okay, now, the only thing here, if you use the equation, is that you're going to have to get the actual percentage, because when you divide by 75, you're going to get the decimal value of the percent. So you're going to have to move it 2 places to the right. So your percentage is actually 44, as 0.44 and 44% are equivalent. Get the same thing here. So you get 75x, 3,300, and divide that by 75, and you get 44 again. So you pick which way you want to go about percentage problems. geometry. So you need to know your formulas. Main ones that you're going to be using are triangle, okay, which looks like it's going to be here. So we have a triangular sail that has an area of 24. So area formula of a triangle is half base times the height. Here we're talking about the perimeter of a rectangle. So if we have a rectangle, we know that the lengths are the same and the widths are the same. So perimeter is the distance around the outside. So we can just double the length and then add whatever double the width is. But I know I don't have a problem dealing with the area of a rectangle, but if you had to find the area of a rectangle, it would be length times width. Those are the three major ones that you're going to be tested on. Now, some things that I wanted to point out is the wording here. So say the length, so we have the length of a rectangle exceeds the width, okay, by 3 inches. So that tells me my length is going to be 3 inches longer than my width. All right, so it's longer because it exceeds. All right, exceeds means that it's longer. So length of the rectangle exceeds the width by 3 inches. Then they also tell me the perimeter is 26. So if I substitute that into the perimeter formula, I have this. And then what's the dimension? So it wants to know the length and the width. So this gets into the substitution. Since L's isolated, I can just plug that in for L. And then I can solve for W. So because I will have an equation. Okay, so I can solve that for W, and then I can substitute that back in to figure out the length. So I distribute. So first rule, you want to combine everything, simplify everything, and then so subtract 6 and subtract 6 and divide by 4. Okay, I get 5. All right, so I have a width of 5 inches. So now that I finally got that answer, I can take that and plug that back in over here to realize that my length is 8, 5 plus 3. Okay, so that's going through systems, and we're going to get into more systems in the next chapter, but then also including the geometry aspect of it. Now this one, they just tell you the area and the base, and they want you to find the height. So this is just a simple substitution. Right? 24 half the base, which is 8, times the height. All right, well, half of 8 is 4, and you divide by 4 to get 6. Okay, and then that's it. So the height is 6 inches. Simple substitution, but you have to know the formula. Now, this one, the first angle measures 3 times the second, so I'll stop there. First angle measures 3 times the second. So with this, I encourage you to label. All right, so we have 2 angles. So we have the first angle we'll label X, second angle we'll label Y, and then we have a third. All right, so and it's going to measure 40 degrees less than the second. So continue on, we have a Z now, and then the second is Y. Also with this one, I want to point out on the test, they usually use less than to trick you with subtraction, as the order will flip as you read it. So if I say 4 is less, what is 4 less than 2? Okay, then you got to take 2 minus 4. All right, so in other words, you have to flip the order. So that's again, less than is a tricky one, and that will definitely be on the test. Also, another important one would be that does the same idea is subtracted from. That is also a possibility on the test because those are the 2 most common mistakes students miss is writing those out correctly. Let's start with the first function, or first equation. So the first angle, okay, is 3 times the second. So again, there would be that relationship. So x is obviously bigger. So whatever y is, you times that by 3, you're going to get x. Now the next one. The third measures, so the third, okay, measures 40 degrees less than the second. So I'm not going to do 40 minus y. Instead, I got to flip the order and do y minus 40. So since I read the y second, it needs to go first. Very important. Okay, and then we got to figure out the measure of each angle. So if we go through, we think we can make a substitution. Okay, but this function does not have an x in it, so I can't take and substitute it, but it does have a y, so I can see both functions have a y, so I could get y by itself and substitute it, but then you would also have, so what the problem is here is that even if I solve this for y, I would not have, I mean I could substitute it, so I say y is the same thing as x over 3, and I can take that x over 3 and I can plug it in for y over here. But again, you still have two variables. All right, so we have, substitution is not going to work because in order for substitution to work, if I scroll back up real quick, all the way up here, you need a function so here's your function of two variables, and then somehow that has to come one variable when you make that substitution so that you can solve the equation. So this we don't have. Now, so in order to solve this, you're going to have to understand that the sum of a triangle, its interior angles, so triangles, interior angles, add up to 180. That's the key here to this problem. So all three interior angles of a triangle add up to 180 degrees. So x, in other words, x plus y plus z is 180. And again, of course, that you say, well, how does that help? That function has three variables, so that's not really going to work. Well, it's going to work as long as they all are going to be the same. So in other words, we'll keep x the same. All right, so my y, okay, let's see if I can highlight this. My y is the same thing as x over 3. So I'm going to represent y in terms of x. And all I have to do is do the same thing for z, which is also, z is also in terms of x. So I can, and I'll just leave x alone. So then I have to actually make two substitutions to make this work. So I have x plus x over 3 plus x over 3 minus 40, and that equals 180. Okay, so let's scoot this over so I can solve this. That has to equal 180 degrees. Okay, now we have an equation for x, and we can go and solve for x. So as far as the left side is concerned, you can rewrite these as 1/3 x's if you want. We talked about earlier that you can multiply by the LCD, which in this case would just be 3, and you get rid of all fractions. Not necessary. Okay, we can easily do 1 plus a third plus a third, so it's going to be 1 2/3 x. And now it's just a two-step process. We add 40, okay, to both sides, and then divide by 1 2/3 to both sides. And when you do that, use the ABC button. So ABC 1, ABC 2, ABC 3 to get 132. So we got 132 degrees, and then that's x. Now we can go back and figure out, okay, well, then what's y? So you take 132 and plug it right there. And then so y would be whatever 132 is divided by 3 to be 44. And then to get z, you would have to do your x again divided by 3, which we already know is 44, minus 40, you get 4. Okay, so there's your three numbers. The key there is knowing the triangle sum theorem and knowing that they add up to 180. So another geometrical property to be aware of. Okay. Last but not least, number 7, the angle measures is 5 times its complement. Okay, complement is another geometrical term that you need to be aware of. Right? First of all, complementary means that you have two angles that add up to 90 degrees, so angle 1 and angle 2. So if we say angle 1 is x, then angle 2 is going to be 90 degrees minus whatever x is, since they both add up to 90. This 90 minus x expression is what it means by complement. Now on your test, they changed this to supplement, which would be 180 degrees. So you have two angles that add up to 180 degrees, which is a straight line. And if this is x, then angle 2 is going to be 180 minus x, and that will be supplement. Now, with this, we have this equation. We have an angle measures 5 times, so some angle, we don't know, so we're just going to label this x. All right, measures 5 times its complement. So again, anytime you see complement, you're just going to replace it with 90 minus x. Find the angle measure, and then we solve that equation for x. So we just distribute through, okay, and combine like terms. So we got 450, and then here's the like terms, and then we can divide by 6, and we can get 75. So it's a 75-degree angle. Now I believe on the test they'll throw in that less than in there, or subtracted from. We actually have to, subtract and switch the order. So it looks something like this, I believe. An angle measures 5 times its complement less than a certain number. So just want to reference the fact, really watch for this less than. I mentioned it here, so I'm not going to do another question with it. Okay, but if they throw the complement in there and less than, just make sure that you switch the order. So I'm not going to do a full problem, but if it says something like an angle that is, let's see, 20 degrees less than, we'll throw supplement. It's supplement, something along those lines, just off the top of my head. Okay, since its supplement comes second, which I told you is 180 minus x, that would have to go first. Okay, minus 20. So that would be that expression, an angle 20 degrees less than its supplement. What is that angle, right? So you would say that, it's equal to x, and you would go through that process and solve that, which is just 180 minus x minus 20. You really don't even need those parentheses, and you would just combine like terms, right? You would simplify and add your x to both sides, and then divide, and then you finally got your answer. So just watch out for the less than. So 160 divided by 2, took me a second there, 80. Okay, now go ahead and try to work out a couple of those problems.